This is Maths Linear Algebra Tutorial 1, Question 3. In this question, we are given a matrix A, and at the bottom right hand corner, this element is A squared minus 14, and A is an unknown. This is x, y, z, the x vector of Ax equals to B, and we are given the B vector, and the last element is also with the unknown A, which is A plus 2. Now for different values of A, you'll realize that this matrix can have no solution, can have infinite many solutions, or only one solution. So the purpose of this tutorial question is to let you identify how A will affect row reduction, and therefore we will be able to identify when we will have no solution, infinite many solution, or only one solution after row reduction. Let's proceed to perform Gaussian elimination on the augmented matrix A, B. This is our A, this is our B. This is the operation we are doing each time, so we will not give the details. You just look at how we are doing each row, the elementary row operations, and we now observe the row reduction. In this case, we are already at the row echelon form. When we reach this matrix. So let us understand when will we have no solution. It is when the last equation, the last row at the row echelon form, the last row, the left hand side versus the right hand side. If the right hand side is not equals to 0, or the left hand side is equals to 0, it means that basically we have, in this example, A squared minus 16 times the last variable z is equals to A minus 4, and when we substitute A minus 4, A equals to minus 4 into the equation, what we'll see is that on the right hand side we'll have minus 8, but on the left hand side it'll be equals to 0, because basically minus 4, when we have substituted into this equation, will be 16 minus 16, implying that the left hand side z is equals to, or we have 0 multiplied by z is equals to minus 8. And this is impossible. On the left hand side we have a 0 value, and on the right hand side we have minus 8. What this means is that the equation given to us is inconsistent, and therefore there is no solution that will solve Ax equals to B for the given A and given B value. In the second case, to have infinite solution, what we need is that the last row after row reduction, the left hand side must be 0 and the right hand side must be 0. This will indicate that we only have 2 pivots and 1 free variable, and this free variable will generate infinite solution. Now for this to happen, let A equals to 4, and then basically you will reduce the equation to 0z on the left hand side, and right hand side will be 4 minus 4 is equals to 0. So we have infinite solution. Now finally, to have unique solution, as long as the left hand side is not equals to 0, the right hand side equals to any value, then what will happen is that we'll be able to solve for z, and this will happen when we set A equals to any value that is not equals to plus or minus 4.